All right, guys. So we're about to begin. Just confirm if you guys are hearing and seeing. All right. So geometry is the content is a lot easier to remember. So what we're gonna do is we're gonna skim through just like to quickly refresh your memory about everything you should know. Um, and then we get into some actual questions, and then we're gonna end today's revision session there. All right, so just give me 2 minutes and then we're gonna begin, okay? All right, guys. So are you ready? If you're ready, type ready in the chat. We're gonna run through the basic geometry concepts first. Then we're gonna get into the more serious topics like circle theorem, Pythagoras, trig ratios, sine rule, cosine rule, bearings. All right, so let's go. We already know what perpendicular lines are. Perpendicular lines are lines that meet at 90 degrees. We know what parallel lines are. Parallel lines are lines that go in the same direction. We know what a polygon is. We should remember the types of polygons. So the smallest polygon is a triangle. So it has three angles, three sides. Then after a triangle is a quadrilateral. Then we have a pentagon. hexagon, heptagon, and this has two names. The next one is septagon. 8 is octagon. 9 nonagon. 10 decagon. All right, we know how to name a line. Lines are created by 2 points, a beginning point and an end point. So a line is created by the shortest distance from one point to the next. So this line would be called AB, right? And similarly, if we are to form an angle is formed between 2 lines and obviously between how many points? 3 points. So this angle could be named angle A because that's the location of the angle, or angle CAB, still realizing that the A is in the middle, and sometimes persons do angle A. All 3 of those notations we must know, we must understand. We should also know that a vertex is the point at which 2 lines meet, and we also call that a line of a point of intersection. So we're gonna go through some other stuff. So we see here types of lines: curved line, straight line. This is just a quick angle. So as I was discussing before, you have angle A, and we should know the types of angles. So we have acute, less than 90. We have right angle, which is exactly 90. We have obtuse, which is greater than 90 but less than 180. We have the straight line or the straight angle, which is 180 degrees. We have the next type, which is reflex angle. And I want y'all to realize in this image, there are 2 angles in each, Anybody realize? There's an internal and an external angle. So for each, there's really 2. You have to also be careful and make sure you know which angle they're talking about. Everybody see that? And the final one is what we call a full turn. A full turn is exactly 360 degrees. This is also affiliated with a full circle. So everybody good to go with those? Just say good to go. Keep yourself mentally awake. We're moving a little fast, but these are things that you should know already. So they are revision content. Then we have complementary angles. So once we have a 90 degree, always ensure you remember to pay attention to the symbols. This box requires you to understand that's a 90 degree angle. If I am to split that angle into 2 or 3, I know the sum of those angles, let's say the angle is A and the angle is B, the sum of those 2 angles must equal to 90 degrees, and we call it complementary angles. The next type of rule that is pretty used often in geometry is supplementary. The word supplementary also means 180 degrees, when angles add up to 180 degrees. So who else type of angles add up to 180 degrees? Angles in a triangle. So we can describe the angles in a triangle to be supplementary because they add up to 180 degrees. Then we have vertically opposite. Vertically opposite angles happen when 2 lines intersect. So here we have our point of intersection, and we see that 4 angles are created as a result. So anytime you see this shape of an X, that's the first thing you should think about. And as we see here, A is opposite to Y, hence they are equal. A big part of geometry is finding missing angles. You have to state the reasons. So these reasons have to be fresh on your mind. So we got vertically opposite, good to go. We have adjacent angles. You should know what adjacent means from trigonometry. Adjacent means next to. So the angle that is next to N is B. The angle B has 2 adjacent angles, Z and N. Okay? So it's just something you have to keep in mind with the terminologies. Now, if you have a point, and at that point, you have several angles created. Those angles, if you look at it, form a circle. And so when you add those angles up, they add up to what? 360 degrees. Angles at a point. These are things we need to remember and easily identify. All right. Moving along. Then we have parallel lines and the transversal. From this one type of diagram, we have about 4 different types of angles. Anybody remember them? The first one is called corresponding. You have to remember these. They come very often. And before I get into that, let me make sure we identify the parallel lines. Boom. It's not lining up, but you get the point. So we have our parallel lines, and this line is what we will call the transversal, the lines that cut the 2 parallel lines. So as I was saying, the first type of angle affiliated with this type of diagram is called corresponding. What does corresponding talk about? Same position. So when it comes to B, who is corresponding to B? Everybody, let's go. Who? Which letter is corresponding to B? It is F, because look at it. B is top left. Look down here. F is top left. So who is corresponding to C? And corresponding angles are equal. So if B is equal to F, who is corresponding to C? G. Who is corresponding to A? A. E. Who is corresponding to D? H. So we have to lock that mentally. Corresponding means they hold the same position. So that's one. The second type that we need to remember, and as you notice, do we realize we got 2 sets of vertically opposite? So we have here these 2 vertically opposite, these 2 vertically opposite, these 2 vertically opposite, these 2 vertically opposite. And in addition to that, we also have something else happening here that we spoke about before. What is that? Isn't this a straight line? So who is supplementary to B? Who and B add up to 180 degrees? C, because look at here. Straight line, right? But isn't there another one that is supplementary to B? Is it only one straight line B is affiliated with? What about a line that comes like this? Isn't another angle on a straight line with B? Who's that? A. So you see, we gotta be mentally open to these options, okay? Everybody see that? So you can get a straight line going across, which is B and C. You can get a straight line coming down, which is B and A. B and A add up to 180. B and C also add up to 180. So there we have that. The next type of angle we have to remember is called alternate. Excellent. What shape we gotta look for the alternate? The Z shape. And we know the angles within the creases of the Z shape are what? Equal. So which 2 angles are alternate? Which 2 angles are in the creases of the Z? Excellent. So that would give me A, we see it here, and G. Do you realize there's a backward Z as well? Anybody see the backward Z? It's a little bit more stretched out. So we see the 2 letters. What 2 letters is affiliated with the backward Z? D and F. Excellent. So D and F. So we know what alternate angles are. Alternate angles are angles affiliated with the Z shape. And that means it is, it was A is equal to G and D is equal to F. Anybody remember the third one? Co-interior. Excellent. Guys, sorry for my writing right now. I'm just so tired. I'm just trying to but everybody understand what I'm trying to write. Y'all following? Yeah, no, maybe so. All right. So let's go. Co-interior. Co-interior. Go over the alternate real quick, no problem. So alternate form by the two parallel lines in the letter of a Z, right? So when you look at it, there are the angles on the opposite side of the transversal. So if you look at it, look at the Z, A is in between. It always happens in between the two parallel lines. So the only options are A, D, and G, and F. But look at the position. Alternate means opposite side. So A is on one side and G is on the other side. See that? So they two are alternate. If I were to go the other direction with my Z, here we see which two angles are on the opposite side of the Z, D and F. Seeing it now? Yep. And that means they're equal. Okay. All right. So let's go now. Next one is when we have co-interior. So we have our transversal and we have our parallel lines. What is the difference between alternate and co-interior? Alternate is on the opposite side, but co-interior is on the same side. So who's on the same side? A and F, but they're not equal. What are they? They're supplementary. So A plus F equals 180 degrees. D plus G is equal to 180 degrees. Everybody seen it? So when you are on the same side of the transversal, that's what you call co-interior. If you got it, say got it. All right, we know that angles or triangles in a triangle add up to 300. Oh, your lord. Angles in a triangle add up to 180, sorry. And we should remember there are specific types of triangle. What type of triangle is this? This is the isosceles. That means the two angles and two sides equal. And which angles are always the equal angles? The one at the base of the two equal sides. So the two sides that are equal create the base for the two equal angles. Everybody see that? So two equal angles, two equal sides. So how do you find M? If they give you B, you would say what? 180 minus 2 times B, right or wrong? What do you do if they give you M and they ask you to find B? You say 180 minus the M, and that answer you divide by 2. Because if you take away this one, what is left is equal. So you share it by dividing it by 2. Okay, very important content. Next type of triangle, the equilateral triangle, where all 3 sides are equal, all angles are equal. So what do you do with 180 if all 3 of them equal? What do you do to find 1? You divide by 3, right? These are things you're expected to know. Then from there, we have internal and external angles. If you are to extend any side, you would create an external angle. This is what we have here. And then you have your internal angle. What do you realize about these two angles? They do what? Aren't they supplementary? So we need to remember this, that E plus C is equal to 180 degrees. That's how you find an external angle or internal angle. Everybody with me? We're going to quickly, all of this is revision. So let's just do a quick practice with this question together. This is a lot going on here, but which one is easy to find? Where would you start? Let's find X first. Let's go in alphabetical order. What do we realize about x? How do we find x? Anybody knows? Excellent. Everybody seen the Z inside of the Z? Because there's two Z's in here, you know. I'm actually really impressed that y'all see it. Look at here. Excellent job. Excellent job. That means your eyes open. So without any calculation, we know here is 28. Very good. Very, 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 very good. Now, what else do we need to find Z and Y? Well, you realize here, if we know here is 28, don't we know how to find this angle here? And if we find both of them, we could find Z. There's different ways to do this, eh? But let me go. Which way y'all prefer to use? So in here is 28. So let me erase all of this. So in here is 28. What do you do next? And you know the reason, alternate angles. Anybody seen the isosceles triangle? Look at it, you ain't seen it. We ain't just talk about how to find a base angle. So this would be almost like our M. So if we want to find this angle here, or even R, because R, let's say we want to find R. What is R equal to? R ain't equal to 180 minus 28 divided by 2. Somebody with a calculator, help me out quick. What's the answer? Was that 152? So 152 divided by 2 is what? 170, 176? No, 176, 76? 152 divided by 2 is 76. All right. I don't even know why I write 152 there. Give me a minute. I just wake up. 152, so 152 divided by 2 is 76. So that means this angle here is 76. How do you think this could help me to find Y? Anybody see what's going on between these two angles here? What do I do to find Y? Why is it 180 minus it? Anybody seen the supplementary angles? Angles on a straight line? These two angles ain't on a straight line. So Y is equal to 180 minus 76. You have to see these things, okay? What's the answer for that? I need you to just rock with your calculators for a little bit. 104 degrees. Now check this out. If here's 104 degrees, what is Z? Z ain't 104 too. Because if Y is 100 and thing, that means here is 104, and that means up here is 104. What do we call that? We use vertically opposite first, and then we use what? Corresponding. So you see how these things could come, right? All right, so let's move on. Now I'm going to be honest with you. The only thing I did not get to teach is construction. Based on what they sent, they said they're not sending any construction, but the textbook I sent out, you have construction in it. So what I would recommend is just read through that section in geometry about how to construct like a 90-degree, certain angles, stuff like that. This has a nice handout. I can send it to y'all if y'all want me to, even if it's just this here, the construction part. Let me know if you want me to send you the construction part alone, and maybe you could practice it. All right, excellent. So let's go. Circle theorem. First of all, do we know the paths of a circle? Do we know the names of the paths of the circle? So we see here, we have the circumference on the outside. We have the tangent, which is any straight line kissing the circle slightly. We got a radius, which is half of a diameter. We got a diameter. And then we did sector in measurements. We know it's like a slice. And we know segment is just like a chip off at the edge. And we know what creates the segment, the chord. Then we know the arc is a portion of the circumference. So we should be good to go with that. All right, ready for the circle theorems? I don't like this version of it. So what I'm going to do is I am going to use another document for this. Give me a minute. Look at here. Where is it? This is it. All right. Let me just erase all of this. This one is the easiest one to use. Okay, no problem. Sorry. All right, let's go. So first thing first, let's look at the theorems that we need to remember by heart. Because remember, part of circle theorem, you got to tell them why you find your answers. And I got some questions that are direct. You could find the angle by a theorem. Some are indirect. You have to find other things first before you find the angles that you need. So you must remember these things. So there we go. First one, angles at the center. We should remember these things. Angles at the center is what? 2 times angles at the circumference. How do we know that we could use this? Both angles start at the same chord. Everybody with me? Second one, then we have angles that are formed on the same chord are twin angles. They are equal. So we see here A and A are equal. If I were to form another angle over here, but from the same chord, we're going to realize we can still get the same angle A. Next one, any angle formed on the diameter or in the semicircle, which is half of the circle, is always what? 90 degrees. Once you're touching the circumference and it is built from the diameter, the angle at the circumference is 90 degrees. Then we have here something called a cyclic quadrilateral. That's when the vertices or the points of the quadrilateral is touching the circumference. So all 4 touching the circumference. What is this law? Opposite angles are supplementary. So if I add A and B, this will give me 180. If I add C and D, this is going to add up to 180 degrees. So before I continue, everybody feel like they got the first 4 lock? You should be refreshed now, but we did this a lot. Let's go, let's go, let's go. Anybody? What about everybody else? So those are the first 4. You have to, I'm telling you now, you don't know them, you're going to struggle. You have to know them 100%. You have to know them. You're supposed to see it. When you see it, you should know, yes, this is angles at the center. Yes, this is the twin angles, angles on the same chord. Yes, this is a 90-degree angle because it's on the diameter. Yes, this is a cyclic quadrilateral. Okay. All right. I sent this in notes, so y'all should have this already. Let's look at the next set. This one ain't so popular. They don't really use it in the theorems itself. But the next one, it is important. Whenever 2 lines intersect, what are the 2 lines we realize we see here? The tangent and a radius. What do you realize? The angle that is formed is always a 90 degree on both sides too, by the way, not just one side, both sides. Next one, what do you realize we have here? We have here 2 tangents. Whenever you have 2 tangents touching the same circle and intersecting at a point, the distance of those 2 tangents are what? Equal. And the truth is, if you connect them, anybody realize what type of triangle it creates? What type of triangle is that? Isn't that an isosceles triangle? Everybody see that? All right. And this one is the one that gives people the most challenge. We got to remember this. And it's both sides. This is called a cyclic triangle because the vertices of the triangle touching the circle. What do you realize about this triangle? It intersects with a tangent. Here, anybody realize we got external and internal angles? So what this theorem says is that the external angle is equal to the internal opposite. So if this is A, out here is A. If out here is B, in here over so is B. And that's the one that students just forget all the time. Okay? So these are the theorems. Out of the 7, because I don't really care about that one ain't really important. Out of the 7, how much you think you're gonna lock? 7 on 7, 6 on 7, 5 on 7. Because you got to know where you're at. You got to know if you remember all or if you don't. All right, y'all ready to try some questions just to refresh your memory? Because as soon as we finish, we're gonna go through 2 questions, and then we're gonna go into trigonometry. Because guess what? We are done with basic geometry. That's it. That's all you need to know for basic geometry. All right, so let's start with. Let me see which one we did not do yet. Let's do this one here. All right, y'all ready to try? What is the strategy with this? Should I start looking at the questions first? What should you do when you first get your picture? Analyze an advanced version of a question. I could find one for you. We could do one, but this is just for revision purposes. At the end, we're going to go through some past papers, which will be question number 3 and question number 9. Excellent. The first thing you do when you get this here is to sit down, get your pencil, and identify all of the theorems that you see. Without even looking at what they ask you for, see which questions you could find by yourself, just from the theorems. So when I look at this, the first thing I see is the tangent, right or wrong? I see my tangent. I also see the radius. So I already know I got 90 degrees right in between here. So if this is 90 degrees and here's 40, what do I realize already in here in 50? Talk to me. Same thing with the other side. The other side over here is 90 degrees. So if here and here is 35, what is the space between here? In 55. You see already, without even looking at the actual questions, I don't find an angle already. All right, let's move on. Anybody see any other laws? You know what other law I see? I see the isosceles triangle. Because this is a radius. This is a radius. So this triangle inside here is an isosceles triangle. Right or wrong? So I know if here is 40, here is 40. And if here and here is 40, what is this angle in here? Then 100. 40 and 40 is 80. So 180 minus 80 is 100. Another law that I see in the angle at the center and angle at the circumference. Excellent. Look at it. Angles at the circumference. Angles at the center. Right or wrong? So I know that I found this already, 100. So if up here is 100, down here is 100, how much is up here? Remember, it's going to be 50 because angles at the center is twice the angles at the circumference. Everybody see that? So look at how we just find all the missing angles without even looking at the questions. Everybody see how it's way easier than if you look at the questions and then you say, oh my God, where'd that be? What to do first? You prepare your mind for the question. OAF, where's OAF? OAF. How you get that? Yep, it is. Because how I want to know how you get that. Look at it. If in here is 40, right? angles of a tree, 15. Good. If here is 55, yes, this angle here is equal to the internal opposite, all of this here. So what is, if here to here is 40, what missing to make it 55, 15? There's another way you could do that as well. Everybody see what angle he's talking about? He's asking what is this little angle in between here? There's another way to do it. If up here is 50, because look at the bigger triangle first of all. Look at the bigger triangle. I know 2 out of 3 of the bigger angle of that triangle, because up here is 50, down here is what? When I add these two together, what is that when I add that together? 75. So I would say 180 minus 50 plus 75. Somebody tell me how much that is, please. That's 180 minus what? 125. So 180 minus 125 is 55. You realize it's the same thing and we use 2 different ways. So you could have used the external rule and just use the external is equal to the internal opposite. Or you could have used the triangular rule. Now, if this whole entire angle is 55 and we know that the smaller angle is 40, we just say 55 what? Minus 40. Everybody see that? So this is a perfect question because this is where we get the indirect question. To find 15, we had to find the bigger one first. So excellent observation. So let me look at the question now. Let me erase all of this so we don't get confused. Let's run through what we have. So first example, EBF. Where is EBF? Follow the lines. Use your ruler. Where's E? E, that's B. B, where's F? F. Boom. So we need this. We don't know what to do. The angle between the radius and the tangent is 90. So we know EBF, you write what? 90 minus 35. What is the reason for that? The reason is angles between what? The radius and the tangent is 90 degrees. Everybody realize how easy this one was? Because to be honest, we found every single missing angle, so you know what to do. So let's move on to something more challenging. I like this one here. There we go. Step 1, identify. I'll take my thing stick. Hold on there. Before I do it, I want everybody to take a minute to identify the actual angles that you see. Y'all hearing me still? Whenever this happens, this is a high probability that my system is going to crash. I don't know. Don't worry, I have my new laptop. I just say so. Eh? Me just say so. I know my laptop's so good. The thing's struggling for a while, but we almost there. So we gotta make sure we just work. So give me a minute. Let me just upload back the program. Here we go. Here we go. Here we go. Where were we? About here? We did. Where's the question? Where's the question go? This is it? No. This one, right? All right, guys, let's go. So take some time on your own. Try to see if you can see all of the theorems by yourself. See what angles you could calculate on your own without even looking at questions. So when I start, you should be able to say, yes, I saw it. I saw that. I did see this. I did not see that. I did know what to do. I did not know what to do. So I'll give you 1 more minute. Mm-hmm. Are you ready? If you're ready, say ready, please. All right. So one of the things I forget to mention before you look at the diagram, make sure you read up here. Make sure everything that they say up here, the information is in here. Because sometimes CXC does do that because they know students don't read. So they will intentionally put information in the sentence and not put it in the diagram. So always do your back checks. Read it. Make sure you see angle 54. Make sure you see angle 20. And all these things. Also, they got some keywords. You see the word diameter. So, you know, okay, ooh, you see the word tangent. So, you know, all these things are things to look for. First thing I see, angles on in a semicircle, angles form on a tangent. I know that the angle up there as well. How much is the angle up there on a circumference up here as well? 90 degrees, right? So immediately I know this angle already. Because if this is 90, this is 20, that missing angle is 180 minus 20 plus 90. So that would be 180 minus 110, that's 70. So me don't know, with my pencil, I took in 70 here immediately. And to be honest, nothing wrong with just putting angles in a semicircle. Save yourself trouble, trust me. All right, next. When you look at what? I see here two tangents. I know these tangents do not connect to any radius because this is the center. So it's not the one with the radius. But what I do know is that they meet at a point. So what does that mean? These two distances is equal. So what type of triangle is that forming? That an isosceles triangle? So that means that this angle here and this angle here is equal. So what do I do to find that? I say 180 minus 54 and divide that by 2. So what is that? That's 126 divided by 2. That's one what? That's 63? Yes, 63. So I know here is 63. I know here is 63. Yeah? All right. So now let's look at the question, see what they're asking us for. Thank you. So I'm going to erase all of this. This is just to open up your eyes to the process and the information. So let's go. MRO. Where is that? MRO. That's the first thing we find in it. Look at that. Just so. Boom. Same thing. Everybody with me? The 70. Just say that easy. And y'all realize how easy it is now when you look for the question before? It's so much easier that way. It's about technique. It's about working smart, not hard. Next. So I'm just going to chuck this in because we don't know why, because we don't find it by yourself. Save yourself time and energy. PMR. Where that at? PMR. Where R is? Ooh, look at this. Look at this. How do we find PMR? This is an indirect question because PMR ain't in between here. Look at what PMR is. PMR is in between here. So is it the 63? No, but you need 63 to find it. The whole entire angle is 63. Right or wrong? So all of this is 63. How do we find that little piece in there? Anybody? Let me erase this so you can see what you're looking at. What you think is 45? Where you get external, internal from? We talking. So one person think it's 20. But how you get 20? This is a straight line. Agree or disagree? Angle M and angle Q? What do you agree with? Talk to me, because I'm not telling I the answer. This is a hard one. You got to think. M and R. Let me look. M and R. What is M and R? This is interesting, you know. I'm going to show you why. Somebody kind of say it, you know. Somebody kind of say it. And I'm going to tell you why somebody kind of say it. If in here is 70, first of all, isn't this a cyclic triangle? Right or wrong? Look at it. Somebody say it, you know, but I don't remember what I read. I don't know if it's the exact same thing. I ain't seen the internal and external angles with the tangent. Somebody say it, right? I think it's Austin. Everybody seen it now? This is not a calculation question. This is a direct question. It just meant to confuse you. That's why I didn't say you didn't have to subtract anything. But everybody seen it? So this one over here is equal to here. Everybody see that? So this is 70. And the 20 is the same thing as over here, 20. Internal and external opposite. Everybody seen it now? So here is 20.
You got two ways to find it though.
It does. It really, really does. What is the next way?
Subtract 90 from 180. You get angle there. And then the angle I've been find there, you subtract it from the answer you get when you find it there.
Agreed. Because watch it. If we add all of these, right? If this is 90, 90 plus 170 is what? 160 in it. And 180 minus 160 is 20. Angles on a straight line. So excellent job, everybody. This one was a rough one. You had to pay attention. And to be honest, don't be afraid to flip your paper upside down. So next one, PMN. PMN. We ain't done find already. $63. All right, so that was an excellent challenge question because it really allowed us to open up our eyes and think. Let's do one more and then we're moving on to trigonometry. And this one, look how much questions you got to find. So let's zoom in first and take a minute and see if you can find all of the different laws. So I'm giving you 1 minute to see if you can see all of the theorems by yourself. Somebody said twin angles. I see the twin angles too. Anybody see anything else? I seen a lot too. I seen a lot. I see angle at the center as well. I see vertically opposite angles as well. I seen isosceles triangle. And I see 3 isosceles triangle, by the way. Yes, angle at the circumference. Anybody seen the 3 isosceles triangle inside the circle? Good. I see external and internal angles. I see in the same segment, yes. What about the radius and the tangent? Anybody seen a right angle triangle? No, this is advanced. Do you see where the right angle triangle is? The 70 degrees in the right angle triangle. You seen it? You gotta look for everybody, you know. You gotta look for everybody. I seen 2 actually. There's 2 right. Yeah, Jerome, very good. Anybody seen the bigger right angle triangle? You get 3. How you get 3? Video. Oh God, I got 1 inside the circle. It's 3 of them for 2, bro. Excellent observation. Anybody see the other right angle triangle in the circle on the diameter? Turn your head to the side, just see. Turn your head to the right. Look at the diameter. So this question is loaded. This is what we would call a loaded question. This is a perfect question to revise. So let me get, I can't find my pen card, get excited. Hold on, dear. I'm always doing this, you know. You find another right angle? No, be honest. You think you could find all the missing angles by yourself? Some? All right, let me go. So I'm going to, you realize we ain't watching no questions at all yet? We're not focusing on the questions. So I'm going to start inside and out. So first thing first, twin angles. They're on the same card. So that's the first twin angle. With the next twin angle right here, which is angles on the same segment, angles on the same card. Everybody see that? Good. Next one I see is angles, and it's 2 of them it applies to, because look at this. Angles, oh, sorry, straight line. Angles at the center is twice angles at the circumference. But look at it. These 2 angles ain't the angles at the circumference. So what does that mean? What is 2 of them up there? If this is 70, this is what? 35. And this is 35. Right or wrong? Everybody see that? I'm going to use another color to not confuse us. Let me go again. We got a tangent. We got a lot going on with the tangent. This is a radius here. So if we look at it, this triangle here is a right angle triangle, because this is 90 degrees and this is 90 degrees on the opposite side. Everybody see that? In addition to that, if I were to take this line, we watch it and go straight up there in another right angle triangle. Look at there. Everybody seen it? So I could find, look, I could find this angle here and I could find this angle here. Everybody see that? So these are questions you gotta find other angles first before you could find these angles there. All right, so let me erase all of that because we still got so much more angles we could find. Let me go. There's a lot of angles. Look at the diameter now. Diameter. Angles formed on the diameter is what? 90. You know, my line never just cooperate with me sometimes. So this angle up here, what this angle up here is? This angle in 90 degrees here. Talk to me. Yeah? So guess what? I could find this angle down here and I could find this angle up here. We don't know this is 35. So if this is 35, we can't calculate this here. If this is 90, that's 35. We could find this angle here, right or wrong. And we could actually find that angle more ways than one. Because look at the isosceles triangle. If there's 70, 70 minus from 180 is what? 110. Half of 110 is 55. So here is 55, here is 55. Everybody see that? And if I wanted to find this extra piece here, what do I do? This whole thing is 90. So we would say 90 minus 55. Everybody see what I'm showing you? I feel like our eyes open. What's another angle that we could find here? Anybody see the vertically opposite? Look at this here now. This is a straight line. So if here is 70, what is here? In 110. And if there is 110, what is over there? 110 again. What is here? 70. Hello? Everybody with me? If this is 110, it's the same thing. 110. 180 minus 110 is what? 70. 70 divided by 2 is 35. I mean, here is 35. Here is 35. What is the angle over here then? Both of them is what? 90. So 90 minus 35 is what? 55. The same 55. Same thing with over here. We know here, we know in between here. So we could find literally every crease and cranny in here. Everybody with me? That was a lot. That was a lot, but I hope everybody was able to follow. And as we see here, we not only made use of the theorems, we made use of the geometry rules, vertically opposite, supplementary, isosceles, angles. So, all right, let's take a look at the actual question now. Calculate showing you're working when necessary the measure of angle OUZ. There we go. OU, where's Z? Z. Look at that. Look at what it starts off with. Let me highlight it. OUZ. But we don't do that already, right or wrong? Because what do we know? Which one we going to use? You see how we did this side? We just do the opposite side. This triangle here on a straight line here with 70. So this angle here is 110. If this angle is 110, you're going to say 180 minus 110, 70. And we know it's 70 divided by 2. Why is that? Because this is what type of triangle? An isosceles triangle. Everybody see that? So the answer is 35. If you got it, say got it. And you realize because we went through it in the beginning, it's easy for us to find it. So let's go, let's go, let's go. If you got it, say got it. All right. No, because I wanted to make sure you understand how to do your working, here's what you're going to do. So let me just erase this. Here's what you're going to say. You're going to say since, you want your full 2 marks, right? Since UOZ, since UOZ, how did I pronounce that? UOZ, that's this angle in here, is supplementary with 70, it is equal to what? 110. Everybody see how you should always state everything, say everything. So, since you call the entire triangle, what's the name of this triangle? ZOU is an isosceles angle. OUZ is equal to 180 minus 110 divided by 2. Put your brackets. And that's how you show your answer. 70 divided by 2 is 35. We don't care. We're not leaving no crumbs. Write everything. Everybody with me? So we're good to go. I could erase this so I could get some more space now, right? All right, let me go. So we know this is 35. In my picture, I'm going to drop in my 35. So I know, boom, that's what I need. So this is 35. You see, when you see 3 marks for a question, no, it's a lot of work, eh? That means you gotta show a lot, eh? So the next angle they ask us for, UVY. Where is that? Look at it now. UVY. But guess what? That ain't easy for us. What triangle that fall inside of? That ain't a 90-degree angle. Look at it. So how do we know this is a 90-degree angle? From here to here is the radius. So that's 90. You have to tell them that you know up here is 35. How do we know this is 35, guys? Angles at the center is twice angles at the circumference. So that's 1 mark. Then you have to show that the angles in a triangle add up to 180. Now, Austin, you put in the minus 180 in the wrong place. The 180 always in front. It's always 180 minus everybody else. So it's 35 plus 90. Everybody with me? So what would that be? 180 minus 125, which is what, 55? So right here is 55. So we know here it's 55. All right, second to last one, UWO. Where that at? UWO. That's easy again. Why is that easy again? That's another right angle triangle, right or wrong? UWZ. Oh, sorry. That ain't even easier because they don't give us the 2 angles. This one is 70 and this one is what? 90. So that's 180 minus 90 plus 70. Everybody with me? So that's 180 minus what? 60. No, give me 60 now. 160. So that's what? 20. Boom. Excellent. Now this is easy. Name the triangle in the diagram which is congruent to triangle. Z congruent means the same size, same angles. ZOU. Where's ZOU? ZOU. If you don't know that, I'm going to be right now. Which is the angle that's congruent to that. What's the name of it? It's right there in your face. We talked about it just a while ago. So let me highlight the triangle they're talking about. This triangle here, who is congruent to this triangle here. They didn't ask you to calculate nothing. What they ask you to do, name the triangle. So you have to call the letters that are congruent to this triangle here. Taylor, that's correct. Jay, that's correct. What is the triangle that's congruent to that? That in this triangle over here? YOX. YOX. They're in the same. Everybody seen it? So your answer is YOX. YOX or XOY. Whichever one, doesn't matter. Next one, YXU. So we need to find an angle that a triangle that matches YXU. Where is that now? YXU. Oh God, that's so easy. Look at it. YXU. What's the name of the triangle that just like that? They're in the twin angles. So what's the name? Somebody. Excellent. Everybody see why it's that? ZUX. Twin angles. Same triangle. Y'all agree? All right, so I think that was a good challenge. Out of 10, how are you feeling about circle theorems now? Everybody feeling a little refreshed? Everybody feeling like they feel a little stronger? No, if you know you're not going to be strong in the theorems, what is your job? Is your job to go and memorize the theorems? You're right. You're right. You're right. You're right. This was a compound question. And if there's any way you could have get confused, there's a lot of triangles inside you. But I think y'all can manage. Okay. Are you ready now for the second half of our session, which focuses on trigonometry? As you know, trigonometry deals with triangles. So that's the first thing I'm on to post about. In the meantime, I need you to tell me if you're ready to go into phase 2. Let's go. So I would say a 5-minute break, not 10. Do not leave. Don't sign out. Go get some water if you have to, because trigonometry heavy. So I just need you to get a quick minute to reset your mind, because trigonometry is a completely different world from regular geometry, as we know. Geometry is angles and shapes and all these things, whereas trigonometry is all about triangles. There was one rule that I don't remember seeing, and I think something in my spirit, something in my spirit telling me about. Make sure I say it. So give me a minute, and I'm gonna send it to you guys now. How do we find the sum of the angles in a polygon? All right, y'all here with me? These are the only two things that we didn't touch on. I obviously taught it before, but that's the only thing we didn't revise while going through the geometry section. Now check this out. Anytime they ask you, oh, you have a hexagon, what is the size of one of the angles? You nobody expect you to memorize that. What they expect you to memorize is how to find the sum, and then you divide the sum by how much sides you have. So these two things you need to know. This is the formula: 180 times n minus 2, where n represents the number of sides of that polygon. That's an easy substitution calculation formula. Then something you also need to know is the sum of all the external angles of any polygon is always 360. Everybody with me? So let's take an example. Let's zoom in here. How many sides does a triangle have? So n is equal to what in this example? N is equal to 3. So let's use the formula and see if we get the correct sum. That's 180 times 3 minus 2, which is the same thing as saying what? 180 times 1. Isn't that true? The sum of angles in a triangle is 180. So that is correct. For a quadrilateral, how many sides do we have? 4. So n is 4. Put the formula: 180, 4 minus 2, which is 180 times 2, which is equal to 360. So the sum of the angles in this quadrilateral is 360. Everybody get the point I'm making? For a pentagon, n is equal to 5. If you need to write down this formula, please do so. 180, n is 5, so it's 5 minus 2. So that's 180 times 3. Somebody, what is that? 180 times 3, that's 360 plus 180, 540. Is that correct? Back check it for me, please. See? Etc., 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 etc. Everybody see that? So these are the two things you need to copy down right now. Even if you have it already, write it down again. When you're done, say you're done, and then we're going right into trigonometry. Even if you don't use it in paper 2, you might need it for paper 1. Just a heads up, tomorrow I am going to do statistics, a quick run through on all the graphs for statistics. Because everything else in statistics is easy. Mode, median, mean is easy. Finding the probability is easy. Yes, I actually have to call I have to call CFBC to confirm, because some year they change it, but it is up the college. For those private students, your exam is up the college. CFBC, you have to be there with your ID. You also need to have all your materials. You cannot carry in any bag, so don't walk with any bag. Walk with something. Your calculator, make sure you have your geometry set. Please walk with all these things. Okay. Yeah, because you are a student, so you could do it in school, but these are private candidates which registered with the ministry, so they have to go up to college. Yeah. What else I was going to tell you? So yeah, as I was saying, so tomorrow I'm not going through the whole of statistics. All I am doing is revising how to do the frequency polygon, how to draw all the graphs them in statistics. So as a frequency polygon, the cumulative frequency curve, and the histogram. Those 3 things I have to make sure I go through so that you remember what to do for each, and maybe do 1 or 2 questions where we answered how to find the median from the graph, stuff like that. Y'all should remember upper boundary, lower boundary, the limits, these things you should remember. Bar graphs are easy. Just in case, please remember how to draw a pie chart. The reason is because Mr. Lewis, he could have asked his students to write the exam anywhere he wants. Because Keon High School had a small group for Agri, he could have afforded to get them to come over there to write the exam. but my students is a few of them, and having them come to GEO N to write maths with a big group of people, not as comfortable. Okay, you see the difference? The exam starts at 9. You have to be there by 8 o'clock. Make sure you're there by 8 o'clock. And the second exam, which is paper 1, is at 1. So make sure you're there for 1 o'clock as well. So be at the college for 8 o'clock. All right, guys, let's get into some trigonometry. So what I am going to do is break down the branch of trigonometry. So if you're ready, say ready. The exam don't start at 8. They start taking students in by 8. Let's go, let's go, let's go. This is a part of geometry students struggle with. So we're going to make sure we clarify as best as I can. We're going to go through every single thing. So I'm going to do a checklist. I'm not going to be able to teach in the full content, but I'm going to try my best to clarify, because everybody should have the basic stuff on lock. So when we're dealing with trigonometry, so let's start off with our tree. In your mind, you should have your information organized like this, because when you see the question, you have to go through the list in your mind and determine which approach is the correct approach. All right. So trigonometry deals with a few things. It deals only with triangles. So you're not going to have to deal with no square, no nothing. So it's triangles. Then there are 2 types of triangles it's divided into. You should know. The first type of triangle is a right angle triangle. And the second one is a non-right angle triangle. Everybody with me so far? Let's go feedback. All I need is feedback. Are you with me so far? So there's 2 types of triangles you're going to have to deal with. The right angle triangle has specific rules. These are the only rules that you use for the right angle. That would be 1, the Pythagoras theorem, and 2, the trig ratios. And when we say the trig ratios, what do we mean? Sine, cosine, tan. When we talk about the Pythagoras theorem, you should remember it out your head. What's the formula for Pythagoras theorem? A square is equal to B square. Actually, it's C square, you know, sorry about that. C square is equal to A square plus B square. And for us to have reference of what we mean when we talk about A, B, and C, let me quickly just do a sketch. Who is always C square? C is always the hypotenuse, and we should know what the hypotenuse is. And then you have A and B, which is the other 2 sides. Doesn't matter who is the A and who is the B. Everybody with me? No. Before I get into the non-right angle triangles, let's go through these 2 concepts that you need to know. So we'll know we're dealing with the right angle triangles. Only 2 rules you could use. You're either using Pythagoras or you're using trig ratio. What is the difference between the 2? Pythagoras, you only use when you're dealing with the sides. How many sides do we have in our 3? If you are given 2 out of the 3, any 2, it doesn't matter which 2. Once you get 2 out of the 3, you use Pythagoras to find the missing side. Everybody with me? So Pythagoras has nothing to do with angles. Nothing at all. It focuses only on sides. Only sides. And how much do you have to use it? Again, you need 2 out of the 3. If you got it, say got it. So you need to put that in your mind. Right angle is either Pythagoras or trig ratios. And you know, if you're dealing with the sides alone, you're dealing with Pythagoras. No, obviously, when dealing with triangles, you're dealing with sides and angles. That's where trig ratios come in. And we should know what the trig ratios are. So if I use sine, what is sine? So we got sine, cos, and tan. Who is always to the top for sine and who's always at the bottom, I should say, for sine and cos? Who's always at the bottom? The hypotenuse. And when it comes to sine, who is at the top? Opposite. For cos, who's at the top? Adjacent. Tan does not deal with the hypotenuse. Tan deals only with sine and adjacent. And who always comes on top? Opposite always comes on top. So opposite over adjacent. Everybody with me? If you got it, say got it. Let's go, let's go, let's go. Excellent. Now we're going to talk about the non-right angle triangle. There are only two rules you could use for over here. A regular triangle that is not a right angle triangle. What is that? The sine rule. And this is given to you where this is on the formula sheet. All of these on the formula sheet, to be honest, even Pythagoras. So luckily for you, you don't have to stress yourself to memorize it, but you have to remember how to use it. So that's A over sine A is equal to side B over sine angle B. What do you need to, sorry. Anybody remember the difference between the cosine rule and the sine rule? One of them, the cosine rule is very long. I personally don't even completely remember all of it because I'm so tired. But do you remember the difference? Yes or no? You can let me know the truth. Do you remember the difference between when to use the cosine rule and the sine rule? So that's one yes, one no. Not really. Yes, yes. All right, don't worry, we're gonna go through all of it. So now that we understand the difference between the two, should you ever see a right angle triangle and think about the sine rule? No, you should not. The only two things you should be thinking about when you see a right angle triangle is only trig ratios or Pythagoras, and you know the difference between the two. When you see a non-right angle triangle, you can't think about Pythagoras, you can't think about trigs. You only think about the sine rule and the cosine rule. All right, so let's get into it. Let's get into it. All of this here we know already. All of this we know. All of this we know. So this is the sine rule here now, right? So there we go. The sine rule can be used to find unknown sides or angle in a triangle which does not have a right angle triangle. We know that. These are the two conditions. Two angles and a length of one side. The lengths of two sides and an angle that is not formed between. So that's the difference. The sine rule, the angle that you have cannot be between the two sides. So if they give you an A and they give you a B and they give you this angle here, you know you can't use sine rule. Who you're supposed to use then? The cosine rule. Everybody understand me? Let me know if you get it. So the sine rule, angle not between. Cosine rule, the angle must be between the two sides they give you. Angle between. So I'm going to say it again. For the sine rule, the angle is not between. The cosine rule, the angle is between. Literally, that's the difference. So let's go, let's go, let's go. We know the sine rule formula because here we see here, boom, boom, same thing. So just zoom in. You see the cosine rule? If they give you this side and the angle in between, you should be good to go. The formula, oh, here it is. Again, don't stress yourself to memorize it because it's on the formula sheet, but it doesn't hurt to know it out your head. A square equal B square plus C square minus 2BC cos A. Keep in mind, this is 2 times B times C times cos A. Okay? I really gained through this quickly because I want us to look at some actual answers. Now we have angle of elevation and bearings. So let me show you something when it comes to that. Sorry, let me go back here. I know this looking a little wild, but I want you to follow me still. Angles of elevation and depression always forms what angle in? Always forms a right angle triangle. Think about it. So when it comes to angles of elevation and depression, you're gonna either always use Pythagoras or Triggs. So this is on the side with the right angle triangle. Versus when you get bearings. Anybody realize bearings always forming a random triangle? So when you're doing bearings, the truth is, guess what you're gonna either have to use? You're gonna either have to use the cosine rule or the sine rule. Everybody see the difference? These two things are an extension of the topics before. Elevation and depression is an extension of the right angle triangle laws. Bearing is an extension from the non-right angle laws. Everybody see the connection? So when you're doing bearings, don't feel overwhelmed. Focus on whether you're using the sine rule or the cosine rule. The only way you're going to use a cosine, the trigonometry, is if the triangle that is formed is a right angle triangle, and usually it is not. So are you ready to look at some questions together? We're jumping straight into the questions. So before we do that, I want to do one example of each pretty easily, like straightforward questions. So let me do that first because I want to make sure when we jump into the harder questions, y'all good. All right. So let's look here. So for the purpose of now, let me start off with a random right angle. I need our to get calculators out, please, because y'all need to work these things out. So when you have your calculators out, say ready, whether you're using your phone, and you better have a calculator for Wednesday. You cannot go into the exam with a phone. All right, let me go. So I give you, let's say 12 meters. I give you here 22 meters. Find M. Here, what's the first thing your brain should think about? I am dealing with a right angle triangle. And 2, what am I looking for? I am looking for a missing side where I am given 2 sides. What rule should you write down? And you should write it down. Tell yourself what to do. What is the rule should we use? It's only 2 options. Is it Pythagoras or is it Triggs? Everybody, let's go. I need an answer, please. Who do we use? Pi or Triggs? All right. So what do we always start with? The formula. C square is equal to A square plus B square. So this is easy because C is the hypotenuse. So to find the hypotenuse, I got to square the 2 other sides and add them up. So let me go. That's 12 square plus 22 square. So let me go. C square. What is C square equal to? That's 144. Show everything. Was 22 times 22. I can't teach and calculate, so somebody got to drop the digits for me, please. Thank you. 484. When I add that up, what do I get? 628. Now, is this my answer? Did they ask us for C square or C? So what do we do last? We square root both sides. Excellent. So when we square root both sides, C is equal to, what's the answer when we square root? 25.06 meters. No, question. How do we know this is kind of right? We know the hypotenuse is always what? In the longest side. So It has to be greater than 12 and greater than 22. So it's looking like we're good to go. Everybody see how to use Pythagoras? Remember how to use it? And if it was the other way around, let's do one more because I want to not take anything for granted. So we're going to do an example of each to refresh your memory. Suppose I give you 5 meters and I give you 3 meters. What is P? Calculate P for me now. And another thing, you gotta move fast. If you don't move fast, you're gonna risk not finishing the exam. You gotta move. So if you see me pressuring you to get me an answer quicker, it's because you have to move fast. And let me explain something to you. This is your strategy for your exam. Do not write the exam from number 1 in order, go back to number 10. You never do that. You do the questions them that you think you can mash up fast. If you know your strength is number 1, 2, 2, 5, 7, then you go to 10. You answer those questions first, maximize your marks, and then you go back to the other questions. Everybody understand me? Never go in order, because if you do that, you might spend time that you could have been maximizing on questions. You could actually get full marks. So that's your strategy. Open the paper. If you read question 1 and you could do the whole thing, you do it one time. And do not, listen to me, do not go and read through the whole entire paper at the beginning. You know what you're going to do if you do that? Let's say when you do that, you see something that you don't remember. You know what I'm going to do to your spirit? You know what I could do to your spirit? You're done nervous already. You're done slightly stressed. That going to just make you feel like, oh my God, I can't remember. You don't ever do that. So take each question one at a time. You open the paper, look at the first one. You can't do it, don't stress, move on. Look for something you could do. The first thing you could do, you do it. And when you're done, literally, you check it off. Because when you visually check it off, when you're going through the paper at the end, you could feel confident that, okay, I did this. And anything you can do in that question, you put this by it. This tells you in pencil that you did not answer it. You need to come back to it. So when you're done, everything that you could do, you come back to it. And when you finish it, you rub it out and you check it off. Everybody understand what I'm saying? Time management is a huge difference between passing and failing. A 3 and a 2. A 2 and a 1. Work smart, not hard. We'll work hard too, eh? Okay. All right, so I see the answers. Excellent job. So usually the formula is C squared is equal to A squared plus B squared. So 5 squared is equal to 3 squared plus B squared. We want B squared, so we transpose. So B squared is equal to 5 squared minus 3 squared. And so what we have here is, you realize I'm bringing it down, 25 minus 9. So B squared is 16. So B is 4 meters. Excellent. All right, so let me run through some of these questions here. Even though the answer is here, when you look at this, what trig ratio is this? All I need to know is the trig ratio. You want H. What is the trig ratio do we need here? We're supposed to be able to answer this fast. What are we given? If this is the angle, this is my what? Opposite. And this over here is my adjacent, the one next to the angle. So what is the ratio that deals with opposite and adjacent? Tan, opposite over adjacent, tan. So you're going to end up with tan 60 is equal to, we got 20 over H. How do I solve this, guys? Anybody remember? What do? We switch H. So H is equal to 20 over tan 60. How do I get tan 60? We put it in a calculator, right or wrong? I'm not calculating nothing. I'm just going through this because we should know how to do these things already. No, I want us to do an example where we got to find the missing angle. So let me go. Let's look at this one. Same concept is applied here. What are we using? What trig ratio are we using for E? Sine, cosine, or tan? I don't like this one. We don't use tan already. Let me use the next one. Let's use D. Sorry. Let's use D. Trig ratio. Let's go, guys. Your brain gotta be moving. Challenge yourself to get the answer quickly. So what you see here, we have hypotenuse, right? And what do we have? Opposite. So how is it cos? What is opposite over hypotenuse? That's sine theta. Everybody see that? So I'm going to work it out just to remind you of how to find it, because it's better to be safe than sorry, right? So first of all, you start off with your formula. So sine theta is equal to opposite over hypotenuse. So let's put in the stuff that we have. We don't have theta, so we got to leave it. So sine theta is equal to 7 over 15. Everybody with me? So sine theta, what's my fraction? What's my decimal? 7 divided by 5 is what? Should be about a half, 0.4 something. Almost 0.5, 0.4 something. Very good. That's it. You write out the whole entire thing at least to 4 DPs. 4, 6, 6, 7. Now from here, what do we do to find theta? Anybody remember? So how do we get rid of sine? We do what? Sine inverse, right? So when you do sine inverse on both sides, so we have theta is equal to sine inverse of 0.4667. Now I need to make sure everybody calculates it okay. Everybody find that for me now and type your answer. I need to make sure everybody calculates a solid. You should get 27.8. Tell me what your calculator give you exactly. If it gives you something weird, tell me what it gives you. You're finding sine inverse of thing, okay? All right, excellent. Excellent. All right, so everybody okay with this now? So you should be able to find both missing angles and missing sides using trig ratios. All of it is the same exact thing. No drama, no nothing. All right, let me practice a question with the sine rule. Let's look at this triangle here. Now, I did a whole class on drawing the images from sentences like this. So if you don't know how to do that, please go and look up the video. It's posted on Google Classrooms, revision on geometry, okay? All right, let me go. When you see this triangle, first thing first, do I think about Pythagoras or trigs? Yes or no? Talk to me, my peoples. No. Why no? Because this is what? Not a right angle triangle. So you only have 2 options to pick from. It's either who? The sine or the cosine rule. Agree or disagree? No. How do we know which one do we use? You only use the cosine rule when the angle given is in between the 2 sides they give. But when you look at what they gave us, you realize they gave us what? 2 angles and 1 side. So who do we choose? Sine or cosine? Excellent. So what is the first thing we do? We write out the formula. A over sine A is equal to B over sine B. And from here, it's all about substitution. So let's go. How do we relate the sides and the angles? Remember, if this is angle C, this is side C. Y'all remember that? And it doesn't really matter what letters you choose. So if you choose this to be A, angle A, this is side A. If this is angle B, this is side B. The angle that is opposite to the side is the one that corresponds to it. I hope y'all remember that. So let's go. What 2 ones do I have both of? So what number should go here? in the side they give us. So 515 over sine what? You see, that's why I asked, you know. If this is side A, which one is angle A? Remember what I just say. Angle A is the angle opposite to the side. You see that, G? So what should I put? Sine 38. Everybody with me? I need confirmation before we move forward. If you got it, say got it. No, let's look at the next one. They want us to find AC. So we could consider AC as B, right or wrong? So this is the unknown side, B, but we have the opposite angle to it, which is what, 60. So we put what? Sine 60. From here, you should be able to take it. Because what do you do next? You find the values of sine 38 and sine 60. So people with calculators, there we go. So that's 515 divided by what? Calculator people, let's go. And everybody should really got a calculator out, huh? So somebody says 0.6156. Good. What is sine 60? And I need more than one person to confirm because sometimes everybody does get different things. So I need to see if everybody getting the same things. So as his Jerome is saying 0.2 something, I seen for sine 38. Let me start over here. What is sine 38, everybody? Which one it is? That's correct. So sine 38 is the 6156. And then the sine 60 is the 0.8660. Tishel, that's what you get when you put in sine 38. What's going on, guys? Hold on there. It's scaring me. Let me go look for my calculator. Hold on there. I think I got it on my phone. Sine 38. Hold on. I got 0.61566. So that's it. Next, find sine 60. If you're not getting these digits, guys, you gotta reset your calculator. I got 0.8660. So we good to go from here. All right, what do we do next? Can't I divide these two values? So divide them and tell me what you are again. 515 divided by 0.6. What the hell did I just write? What is this supposed to be? You see what you got to write properly in general? 56. Thank you. So what our answer is there when we divide those two things? Keeping in mind, we follow in the steps. So out of a class of 15 people, nobody can tell me what we get yet? What's going on? There we go. 836.582. You always use more than one decimal place until the end. Do not round off in your working, okay? Good. So this is equal to B. How do I find B, guys? What do I do? If I want B, what should I do? Multiply or divide? We transpose, right? But how? Yeah, you gotta get rid of what in the denominator. So you multiply by 0.8660. What you do on one side, you do on the opposite side. So B essentially is equal to 836.582 times 0.8660. How much do we get? You're gonna get a smaller number than 836. Maybe like a 5 or 600 and something. 700 and something. All right, 724.48. Excellent. And what's my units? My units would be what? Meters. So we good to go. Everybody see how we found use the sine rule. Everybody okay with using the sine rule? Let's look at another diagram. I'm not working it out, but just looking at it. Here we have what? We have two sides and an angle, and they want to find this side. Where do we realize this side is? This side what do we use? You realize we have the opposites and we need the opposites. So again, we use what? The sine rule. Everybody with me? No, I'm gonna tell you something. You see, if this wasn't here, let's say this wasn't here. You think we could have used the sine rule? Be honest. Look at it. If this was not here, what we would have had to use, we would have had to use the cosine rule. Everybody see that? Because this angle fell in between the two. Actually, no, that's correct. Yeah. Because this two is where the angle is. You realize it doesn't fall in between it? Sorry. So yeah, that's correct. The angle that they want is not between the two sides. So here is the sine rule. Very good. And we know how to use the sine rule to substitute. Let's do an example with the cosine rule and then we're moving on. Let me see. I think this diagram gets shifted around, but that's okay. Anyways, we're gonna be able to do a lot of that. Look at here. All right. So here we see, look at this diagram here. What rule do we use here? The angle is in between the two sides. So what rule is this? The cosine, right? So we're gonna do this one. And another example is if you get all three sides, you could use the cosine rule as well. All right. Should I calculate it? Should I work it out? Yeah, I want me to work it out at least once so you could remember. All right, let me do that. It's a lot of work. It's a lot of work. So let's start off with the formula. So you're just paying attention to make sure you remember. So formula is a square is equal to, me forget to know, b square plus c square. Is it minus 2 bc cos a? Yeah? No, they ask us to find PR. And if this is what we call angle A, which is the cos A, this really represents what letter? This wouldn't be A. So we use the right formula, we use the right thing. So let's go. Any one of these here could be B and anyone could be C. So this, let's say this is B and let's say this is C. So people with calculators, let's go. Because we know this is not hard, it's just a lot of work. So we're gonna end up with 15.2 square plus 9.7 square minus 2 times 15.2 times 9.7 times cos 30. Everybody agree with this? So let's go make people's 15.2 square is everybody agree? I just need one other person to confirm. Excellent. 9.7 square is I just need one more person to confirm 1994.04. Excellent. Next, here's how you treat this part. This is really 4 things you're multiplying. You're multiplying 2 times this first. And then you find out what the value of cos 30 is. Everybody with me? So somebody multiply 2 times 15.2 times 9.7. What do we get? 294.88. Excellent. And times, what is cost 30? Somebody go shine. Okay. All right. Now let me pause right here. Let me stop the music. Students, let's get here, and for some reason, they just fall into shambles. What does bond mass say? Bond mass say we gotta do what first? Multiply, right or wrong? So these two, we could do two steps in one. So we could multiply these two, bring back down the subtraction, and add these two. Everybody see that? So let's go. When I add these two together, what do we get? I see 3, 2. Yes. 325.13. Subtract. Good. When I do the multiplication, what do we get when we multiply? When we multiply 2.94.88 times 0.86, that's what we get. We're supposed to get a number less than 294. Check it out, you see. So you should know that's a mistake. So somebody said 255,366. Okay, good. All right, so let's subtract now. Keeping in mind, what have we been finding this whole entire time? Yeah, I realize it's a square, a square, a square, a square. So when we subtract it, what do we get? $69.764. So what would be the last step though? What's the last step if we want a and not a square? We got a square root both sides. So a is equal to 8 point something. Yep, 8.35 meters. Everybody see how we use this cosine rule? You realize the cosine rule is just all about what? Ain't just substitution and making sure you follow through with the steps correctly. So what we've done so far, we've done sine rule where you're finding either a missing side or a missing angle, and the angle or this angle cannot be between the two given sides. Then we did the cosine rule where the angle is in between the two sides that they're given. That's it. So we are good to go, right? Now, out of 10, how you feel now about the 4 of them? So when I mean the 4, you got Pythagoras, you got Triggs. And you know this dealing with what? The right angle, right? And then you have the normal triangle, and then you have the sine rule and the cosine rule. How you feeling about the 4 of them? Are watching? All right. Don't stop posting your skills. Let me know. Because the truth is, tomorrow I'm gonna try to just recap a few things. So for example, tomorrow after I do the graphs demo and I do 1 or 2 questions on investigation. And when I say investigation, what I'm talking about? I'm talking about the question that deals with the patterns and the table and drawing the image that you have to draw that come after. I'm gonna do 1 of that just to refresh your memory, and I'm going to go into functions. So I'm gonna do a quick example through functions. That's compound functions, inverse functions, composite functions, solving, and the graphs. Remember the graphs? You got to remember how to find the gradient, how to find the length of a line, how to find the midpoint, all them kind of things here. I'm going to go through tomorrow. Quickly, not fast. All right, so let's get into angles of elevation. The truth is, you see this image in your mind, you have to remember it. If it's angle of elevation, you're starting from the baseline. It's always in relation to a horizontal line. It does not matter. It's always in relation to a horizontal line. So if it's the angle of elevation, you're going upwards from the baseline. If it's an angle of depression, you're going downwards from the horizontal line. And if you look at this, wouldn't this line be parallel to this line here? What type of angles is alpha and beta? What type of angles are those? They're in alternate angles. So whatever this angle is here, is this angle here. And the truth is, anybody seen a triangle? You always find a triangle. This in the right angle triangle. And this one give you two right angle triangles. This in the right angle triangle. The key to angles of elevation and depression is finding your triangle. Once you find your right angle triangle, what should you be using? You're going to either use what? Pythagoras or what? Triggs. So I'm going through all of this here. We're skipping through all of this here and we're going straight into exam questions. And once we finish this and bearings, that's it. Ooh, transformations. Lord Father, help us. We did this already though. We did the rotation, enlargement, translation. I just really want to do the matrix version of this. I don't know when, but I want to do the matrix transformation because they say definitely coming. So that's the only thing we didn't do last night for matrices. But we definitely killed rotation, transformation. So we're going to stop here at bearings. So I'm going to do one question from angles of elevation and depression and one question from bearings. And then we're done. All right. Let's look at one that we have to read and they didn't give us a picture because that's the worst case scenario that could happen. If they don't give you the picture, if they give you the picture, it's easier because you use it to reference it. So y'all ready? So one question, angles of elevation, one question, bearings. All right. A sailor 100 meters above sea at a coastal lookout point sights a boat at an angle of depression of 727 degrees. Calculate the horizontal distance of the boat from the sailor. So let me look at this now. How much people could sketch this? That's the best question I could ask right now. If you were to sketch a diagram, can you sketch a diagram from this? Are you able to sketch a diagram from this information? Yes or no? Austin said absolutely not. No. Guess what picture you should have in your head? In either the first picture or the second one. Hello? Which diagram you think you got to draw? It's only these two, you know? And you know what people don't realize is way simpler than you think. Once you're organizing your brain what to do, you're not going to be stressed out. It's either an angle of elevation or angle of depression. Which one it is? In a depression, it tell us. It didn't tell us what type of angle we need to draw. You realize they tell us? So which one do we draw? The first one or the second one? So I'm going to go back because it's in this. I need everybody to sketch this in your books right now. Just how this here is, you have to get, because if you can't sketch this is the basic sketch you always draw. No matter what they talk about. If they talk about a coconut tree or a lamppost, it always comes down to this picture, one way or the other. So take a minute and draw this, and then we're going to get into the actual question itself. Y'all finish? Y'all done? No, another thing I'll take this opportunity to see. Let's say from the first instance you read something and it's overwhelming. I need you to not give up immediately. I need you to start with something, and from something you might end up trigger a memory. The point I want to make is that you gotta fight, And I'm gonna tell you something. When the markers for math specifically, watch your paper. They just mark at a table, one question at a time. So if you write absolutely nothing, what have you told the examiner? You ain't willing to try, you ain't willing to think, you ain't willing to solve nothing. But if you sit on there and you try to sketch something, even if it ain't 100% correct, they are more than likely to give you something because of your effort. You understand what I'm saying? There's also something called error moving forward. So let's say you make a mistake in one step. And when you move to the next question, you needed to use the answer, but you did that part right because you know what to do for that part. Even though you do the part before wrong, you get full marks. If you write nothing at all, can you get anything? So I am telling you now, go into the exam mentally prepared to fight for your life. It's going to be the hardest exam you do. I'm telling you straight up. Because maths is never the same question coming, even though it's the same topics. You have to be willing to fight. Write something, say something. You can actually write a sentence saying, let's say you forget how to use the cosine rule. Write down, because this is this, you use the cosine rule. Oh, because this is a right angle triangle, you have to use Pythagoras theorem. Even if you ain't even use it. Everybody understand what I'm saying? If you do the right working, let's say it's 3 marks, you most likely get 2.5. If you use the wrong number, but you do the correct working, you could get full marks. And remember how CXC is marked. You could get 40%, but let's say across the Caribbean, 40% is the highest. You get a 1. Suppose everybody else do way worse than you. You get a 1. So you can't think about passing as a number. It really comes down to what you do. You have to think it's not in relation to you. And I'm going to tell you the truth. Jamaica and Trinidad do not play with maths. So in your mind, you got to think, I got to get as much marks as I can so I could hit the scale in a good place. Everybody with me? All right, so there we go. We understand how angle of elevation and depression looks, so we're going straight to, I'm just going to draw the question. So just follow me and make sure you understand. If there's something that I do that you don't, you let me know, okay? Because I know this is an angle of depression, I know that this is how my drawing is going to look. Because where is the man? It says a sailor is above sea level. So the man ain't up here. And he looking downwards. So this is going to be the cliff, because it's a lookout point. We know how a lookout point look, in it. So he at the top of the cliff and he looking down. So what does all of this represent? They saying represent the seawater. And this wouldn't be the location of the boat. Everybody see that? But guess what? Nobody care about them things. You know what we care about? The triangle. Where the triangle at? Everybody see the triangle? So check this out. Because it's an angle of depression of 27, what do you know? That means in between here is what? 27. And because we know already that this is alternate angles, we know that this angle is also what? In 27. So let's see what they want us to calculate. Calculate the horizontal distance of the boat from the sailor. Wouldn't that be here to here? What information did I forget to put though? You must put in what? The right angle. And it also said that he's 100 meters above sea level. Where do I put the 100? Here or here? Left or right? Excellent, right. Everybody see how I get my picture? No, this ain't a right angle triangle. So what should you be thinking about? Pythagoras or Triggs? Who we need to think about now? Who are we thinking about? Triggs. Everybody agree? And the distance we want is the horizontal distance. So let's label this X, because we always use X to represent some unknown value. No, since we want X and they give us what? What did they give us? They're saying the opposite. They're saying the opposite. And wouldn't X be the adjacent? So what trig ratio should I use? Tan. Everybody realize it always comes down to the triangle? Talk to me. So tan theta is equal to opposite over adjacent. I'm telling you now, do not let all these extra words confuse you. What you need to do is find the triangle. Once you find the triangle, you know what you need to look at. Is it Pythagoras or is it Triggs? And both of them you know how to mash up. So from here, let me go. It's going to be tan 27 is equal to opposite, which is 100, over adjacent. How do I get adjacent? What do I do? Switch, right or wrong? Once the thing that you need is inside the denominator, you switch. So adjacent is equal to 100 divided by tan 27. May need to work out this because everybody know you find tan 27 the value and you divide 100 by it, and that's your answer. Talk to me. Everybody with me? So that's it. That's literally it. Now we're going to move on to bearings, because bearings is the same thing when it comes to triangles. And I'm going to use, let me see, I want a hard one. This looking hard, but it kind of easy. It only look hard. But let me do the first one. The first one got way more questions, 5 questions there. So bearings. First thing first, we write bearings with 3 digits. So 90 degrees in bearings is 090. Everybody remember that? We also measure bearings from what? Let me just go back to the summary notes so that we could just get this clear. I'll just read through these notes. The 4 coordinates directions are north, south, east, and west. The position of an object relative to another object is called a bearing. The bearing is measured clockwise from the north object. Bearings are always written using 3 digits. So if we see here, that's how we represent it, right? So I'm just going to do a quick example. If I want P is 120 from M, who is the point that we draw first? Who is the point that we draw first? And to be honest, they never really asked you to draw a bearing, but I'm just doing it just in case. Who is the point you draw first? Do we draw P first or do we draw M first? You always draw the one that says from first. So you're going to draw M. From M, that's what we do. What do we do from M? We always draw what? Our knot line. And from here, we measure our bearing. Let me use an easier bearing rather than 120. Let me say 45. From here, we measure, this would be 0 and you're counting. So 45 would be about halfway, because let's be real, from here go across would be 90. So 45 would be like half of that, right? So 45 would be like this. So at this point, I would put what? What would I put at the end here? What point I would put here? P. Everybody see that? Because this would be my 90 reference. So everybody remember how to read a bearing, how to measure a bearing, how to sketch a bearing? That's the basic concept. But guess what? Just like angles of elevation, what was the real focus of angle of elevation in the right angle triangle? The real focus of bearings is the regular triangle. Look at here. You realize bearings is just the data around the triangle. But the real truth is that guess what you're going to really be using in bearings? Either the cosine rule and the sine rule. To be honest, bearings is an application of these two rules. Just like how angles of elevation is a real life application of Pythagoras and trigs. So don't get confused. Make up your mind. In bearings, it's either the sine rule or the cosine rule you're using, because that's the true reason of the topic, to test your understanding of the sine rule and cosine rule using a real life situation. So y'all ready for me to go through this? Because this is the last one, eh? So I need you to focus. If you need me to explain something, you ask the question or you ask me to repeat or go over it again. I will. All right. So step one, what did I always teach you? Read this thing up here. Sometimes they give you information that they don't put in the picture. So you have to make sure you have everything. So let's go. The diagram below, not drawn to scale, shows our relative positions of 3 fishing boats. What are the 3 fishing boats? K, L, and M. So we see these are 3 different fishing boats. L is on a bearing of 040. Is that in the picture? So guess what I gonna do? I gonna put it in, because look at it. L is on a bearing from K. So that means from here to here is what? In 40 degrees. Everybody talk to me and make sure you understand what I just do there. So already I done got one angle in the picture that wasn't in the picture. And M is due south of L. Let's look at it, south of L. Everybody see that? Do you know what that means? If something gone south and this is not, do you know that these 2 lines are parallel then? Anybody realize that? Because when you're using bearings, if somebody say you're going south, that ain't directly parallel to north. Talk to me. You see, anytime they tell you south, you know what to think about. Suppose they tell you east. If they tell you east, what angle east would represent? East ain't gonna represent 90 degrees. Everybody talk to me. Because if this is not, if this is east and south is straight down, south is how much degrees? 180. And west, you got to go all the way around. West would be what? 270. Okay, keep these things in mind. Bearings, the rules, the angles affiliated with the directions. So as I was saying now, because this is going south, south is parallel to the north line. So anybody see the alternate angles already? Because me don't see it. Anybody seen the Z? Turn your head to the left. So without calculating, what angle do I know already? May I know this angle in here? That's an alternate angle. Look at it. Look at the Z, the creases of the Z. They expect you to know these things, you know. So when they tell you the word south, everything they tell you is intentional. These are clues. This is information you have to use. All right, so let me go. Let's look at the questions. On the diagram, show the bearing 40. We did that. That's correct. Calculate the measure of KLM. KLM, look at that, boom. I see how we did that already so fast. And what would you write? KLM is equal to 40 because it is alternate to 40 degrees here. Now let's get to the real stuff. Calculate the length to the nearest kilometer. That means you need a whole number. Anytime they say to the nearest degree, the nearest centimeter, the nearest kilometer, they want a whole number. So what are we looking for? KM. Where is KM? So let's call this A. I want you to look at this diagram and tell me what law we're going to use. Is it cosine or sine? Which one? Kayla thinks it's cosine. Everybody got to talk to me. What do you think it is? Look at where the angle is. The angle is in between the two given sides. What rule do we use when the angle is in between? Everybody with me? The cosine rule. External, no. You know why? Because this is not a circle. If it was a circle, yeah, but this is not a circle. Those rules, external and equal, internal opposite, is only for circle theorem. It don't work outside the realm of circle theorem in all cases. So it's not a reliable approach. When it comes to this triangle, you only got two options, only two options. Okay, so question, everybody know how to do the cosine rule, right? A square is equal to B square plus C square minus 2BC cos A. And if you look at it, A would be what? Cos A would be 40 degrees. So everybody think they could substitute and calculate it now after our example before? Because I don't really have the energy to go back over this. If you want me to, I can, but I think y'all should be able to substitute because it's just replacing every single thing and then working it out correctly, right? All right, so I'm gonna make up an answer. So let's say this is, let me see. Let's say this is a number. Let me estimate it, give me a minute. It got to be less than 120 because 120 look like the longest side. So I would say in between 80 and 120 is 100. So let's pretend that the answer we got is 100 km. That's not the actual answer, guys. Everybody with me? I'm just making an estimation. All right. Calculate the angle LKM to the nearest degrees. Where is that? LKM. Where is that? LKM. That's this angle in between here. Now, what rule is that rule now? We got all three sides and we got the opposite sides and the opposite angles. So what rule do we use now? This ain't the sine rule. Yeah. Because look at it. You remember you have opposite sides matching with the angle. Right or wrong? So what is the formula? A over sine A. This is a past paper exam, actually. You know that? This is past paper exams we've been doing. Oh, not tonight, boy. Not tonight. Not tonight. After you finish this, that's it. B over sine B. So I want you to substitute the values for me. Let me see if you understand how to substitute. Let's go. What would be A? What digit is going to be A? The A to the top. Excellent. You use the two pairs that you have already. So you're going to put 100 above here. Very good, guys. Over sine what? Excellent. Equal to B. What is the value of B? Excellent, because you want this angle, so you got to use the side opposite of it. So you get 120 over sine theta, because we don't have sine theta. Everybody see that? So when you finish, you're going to get a number over here. So let's say you get 26. 26 is equal to 120 over sine theta. What do you do next? Because we want sine theta, what do we do next? We switch, right? We transpose. So we're going to end up with, come over here, sine theta is equal to 120 over 26. And when we do that, we're going to get an answer. So sine theta is equal to 4 point something. Let's say 4.3. How do we find theta? Because it's the angle that they ask us for. What do we do when we want the angle? And sine inverse. Yep, so you sine inverse both sides. So theta is equal to sine inverse of the answer that you get. And guess what? We've been doing this all before. So now that we are done, let's go back over the list. So you have to tell me how you feel about each. Good, not so good, great. That's the three options. Great, good, not so good. So start off with the first one, Pythagoras and Triggs. Or should I do each separate? Let's do each separate. Pythagoras, let's go everybody. The first one, how you feel about Pythagoras? I'm watching. So that's the easiest one. But you express yourself. Let me know the truth, how you feel about it, because I'm taking notes of everything that we struggle with to try to touch upon it maybe between Monday and Tuesday. 2, Triggs. And Triggs to find the side or to find the missing angle, because you know it's both of them. Let's go. Triggs. So I see persons are less confident with the tricks. That's okay. Okay. Now let's go into the non. And honestly, from this, what do we use? We use the angles of elevation and depression. Because you remember, this is an extension of those two things. So how do you feel about the third thing, angles of elevation and depression? Step 1, find the triangle. So how you feel about this one? I like that one, goodish. You're goody. All right, now let's go into the dark side. Dark side. First rule, the sine rule. How you feel about the sine rule? Remember, the sine rule, the angle is not in between the sides, between the sides. And this is non-right angle triangle. Once you understand better, that's all I really want. And I want you to be able to see when to use it. That's the most important part, because to be honest, you should be able to substitute correctly. And that's where students go wrong. They don't know which one to use and when to use it. All right. 2, cosine rule. And remember, we use the cosine rule when the angle is between the two sides. So we should know the difference. Remember the difference between the two. And as an extension of that, do you realize bearings is a combination of these two rules plus the other angle rules? You realize that, right? So bearings, just use the sine rule and the cosine rule, and alternate and parallel and corresponding. They use the other rules of angles to also find the information they need. Okay, so I think tonight was a successful session for geometry. I'm going to tell you, so tomorrow, what I am going to go through is statistics and all the graphs. Anybody got exam on Monday? Because I need to know how late we could go. Anybody got exam on Monday? Is there an exam on Monday? Perfect. Because unlike Tuesday we cannot go late. Tuesday is English. But to be honest, English ain't even like that serious. I just needed to make sure nobody got exam tomorrow. I am thinking to stay home from school. When is your ELEC? When is your ELEC exam? Jesus Christ. Well, you know, you have to evaluate how you feel because Jeremy, I'm gonna be honest, you're strong. So it's really how you feel and what you need. If you think you should be good, you don't have to attend, but I'm just gonna be available for those who want it. All right. Now, as I was thinking, should I stay home from school? Anybody would want a session in the early morning, like in the morning, evening. So here's what I'm gonna do. I am going to stay home from school tomorrow and have some sessions with anybody on even algebra and stuff that y'all need. But in the evening, I'm going to do a class from 6 to 7. The class from 6 to 7 is going to be just for statistics, and I'm going through just the graphs them alone. Just the graph, everything else you got to revise on your own, guys. But I personally just need to go through these graphs because students just lose a lot of marks for the graphs. And when I say the graphs, the histogram, the frequency polygon curve, the curve, and the frequency polygon, the polygon itself. So tomorrow evening, that's all I am doing. And maybe go through some functions questions. But I don't want to pass 7 o'clock because I want y'all to be free to just revise your English and to get enough rest as well. Because English is a lot of writing, right? So those who are available tomorrow, I'm going to send a WhatsApp message and we're going to organize a time for us to do a revision, okay? All right. So that's it for tonight, guys. Y'all okay? Y'all feeling better? How y'all feeling? Overall, with everything, the whole exam itself. I hope y'all ain't feeling stressed there. Do not feel stressed. Be confident. Be confident. Even if you know you got some things you don't know, that's okay. I've had students and I taught them for 2 weeks and they pass. So it's all about just being mentally prepared. Okay, so that's it for tonight. See y'all who gonna be here for tomorrow. See y'all tomorrow, but stay positive, okay? And good luck to everybody. Bye.
Bye.